In this class, we're going to look at set theory. Don't go away. I will try as much as possible to make set very easy for you. Any question in set will be very easy for you. It means after this video, you're going to get another video on set, another video on set, another video on set. We're going to look at a lot of problems with solutions, exercises and solutions. So don't run away, because this is the lecture you have been waiting for when it comes to set theory, okay? The first thing we need to do, let's define set. What is set? Set is a collection of what? Distinct objects. A collection of what? Distinct objects. When we say distinct, we mean unique, no repetition. For instance, a set of numbers. It means when you are writing them out, you're going to have 4, 7, 8. There is no way you see 7 again if it is a set. Because this is not distinct, there's a repetition. So there must be a collection of distinct objects. The family of numbers without repetition. The family of fruits without repetition. I can write here orange. For instance, let me just do it like this. Say mango. And so on and so forth. The collection of what? Fruits. A collection of alphabets. A collection of prime numbers. A collection of even numbers. A collection of odd numbers. These are what? Set. Set of numbers. All these are called what? The element of a set. Themselves are not sets. Is the group of numbers we call set. Each of them is element of the set. It's like you are a member of a family, but you alone, you are not a family, a member of a family. Okay? Element of a set. To represent these elements of a set, you put a curly brace. This is called curly brace. Then you put the element. Say I put 1, 2, 3, 4. So this is a set now. I cannot say, for instance, A is equal to this. So A is a set. These are the elements of A. Okay? For instance, I want to write 3 as element of A. I will say 3 is element of A. That is, you are a child of A. You are a daughter of A. You belong to the family of A. Okay? Say, for instance, this is August family. August. Okay? We have Vic in the family. Okay? If I put this now, it's like I'm writing a program. If you are doing coding, you must put, I'm thinking that I'm doing programming. Okay, let's just follow it like that. Say this is Vicky. I'm just shortening it. This is Jane. This is Mike. Let's say MI. This is what? A string in programming. Okay? And when it's a string, you must put what? Quotation marks. Okay? So this is family of August. Okay? This family of August, these are the elements. So you are part of August. So this is a set. Okay? A set of alphabets. Say you put A, B, C, D. Okay? Now, let's look at types of sets. We have the finite set. The finite set. When we say finite, it means it has beginning, it has an end. For instance, if I do this, 1, 2, 4, 7, as you can see, there is beginning and there is what? End. We also have infinite set. Infinite set. So you can see, it means it has no end. That is, for instance, I write 1, 2, 3, 4. This is what? A set of numbers. A set of what? Numbers. If I put this here, as you can see, it means that this is what? Infinite. You can continue to write them as long as you want. How would you interpret this and this? This means these are the only elements of this set. This means that what? There are more. That means after 4, you can write 5, 6, 7, 8, 9, 10, 11, 12. You are still correct. We also have equal set. Equal set. As the name goes, it means that what? The sets are equal. For instance, say A is equals to 1, 2, 4. Say B is equals to 1, 2, 4. It means A and B are equal. Okay? Set A and set B are equal. So they are equal. We also have the null set. Null set. You can write it as what? Empty set. Okay? This means you can represent it like this. There is nothing inside. How many elements are you seeing here? 0 element. No element. So it means it's a null set. There is nothing inside. This is representing one null. We also have singlety. Singlety. You that is single. Singlety set. A singlety set, as it goes, you are alone, like a single. You are not married. Nobody is with you. It means that set has just one element. Only one element. For this, I put 1 here, or I put 5 here, or I put A here, or I put D here. What you will see inside is just one element. Whenever you see any set with one element, it's called what? A singlety set. Okay? Now, we look at subset. Subset, as the name goes, is a sub of another set. Say, for instance, you have A to be equals to 1, 2, 3, 4, 5. Then you have B to be equals to 2, 4. Everything here are also here. This is a subset of this. It's a subset. How do you represent this? We say B is a subset of A. What is this? You write this mathematically, less than. That is the picture you should look at. This is less than this. It's properly less than. When we say properly less than, it means everything here is here. There are some that are here that are not even here. This is the guru. This is the boss. You are the child. This is your father. You are coming from here. You cannot be bigger than your father. So you are a subset of your father. Okay? So we write it like this. A proper subset. There are some things your father has, you don't have. So a proper subset. But if, for instance, we say C, or let me say D, is equals to 2 and 4. 2. As you can see, B and D, they have the same element. They are equal set. They are equal. We can also say what? B is a subset, but not a proper subset, but what? Normal subset. It's a subset of D. B is a subset of D. This is a proper subset. Proper subset. Okay? Why this one is just a subset? Okay? As you can see, this one is what? Less than or equal. Actually, this B is not less than D. So this upper side is what? Is a loss. But this one means equal. It's like we are saying less than or equal to. This is not less than, but they are equal. Less than, or it could be less than, it could be equal. So this is what? How to represent this. Also, this one you represented as proper subset. You can also put this here. Actually, this part is not correct. They are not equal. But this upper side, B is less than. It's a subset of A. But the best way to represent this is to simply put this, that is, this. So what we are saying now, other subset, we have to type, that is a normal subset and the proper subset. That is, you are really a sub. You are really a sub of that guy. You get it? Good. The power set. Power set. Okay? If I said D is equals to A, B, C, D, E. Okay? Let me not put D here again because of what I'm doing there. Let me put V here. Okay? And I say K is equals to, say, B, C. Just the way I did the other one, I'm just writing something else, okay? Just to explain this. It's simple. You agree with me? K is a subset of V, a proper subset of V. Abi? Right? Okay, good. As you can see, this is facing this side. I can write V as, I can write it like this. That means V is a superset of K. You are the Oga, you are the boss, you are the king, you are the head, you are the father of K. Just like this one we did, okay? This is what? A subset. We also say proper subset. We also have proper superset. Like this one, I can call it a proper superset because there are some things that are here that are not here, but everything here is here. So this is a superset of this. Also, this one we call, that is proper subset. For instance, it's a proper subset. B is a proper subset of D or whatever. We can also have proper superset and superset. When you are superset, it means we have to consider you like this. That is, you are superset of K. This is what? Proper superset. So the next thing is universal set. Universal. What is the meaning of universal? It means everything other consideration is inside here. As far as this world is concerned, the universe, God made the universe. Everything you ever need is on Earth. Not only the Earth, you can go to Mars, you can go to other planets, the universe. So if you want anything that is not in the universe, you are just what? Something else. The same thing for universal set. If I say A is equals to 1, 2, 3, 4. So you can see, I'm referring to all natural numbers. All the numbers, not only stopping at 4, continue. Even though if I don't write this, if I define this now, if I put this now, I say, this I want to define as a universal set. How do I represent it? I represent it like this. You can also represent it like this. Universal set, okay? When you see universal set, you see this. It means these are the values under consideration. As far as that question is concerned, there is no value you will see that is not here. If you check, for instance, Venn diagram, which we are going to look at later, you see 7 in that Venn diagram, but they are telling you that the universal set is this. It means it's a wrong answer. It is not correct. Okay? So you have to understand this is what? All the elements under consideration. None is here. So if I want to take A now, I will take A from here. If I want to take B, I will take B from here. If I want to take C, I will take C from here. It means I can say A is 1, 3. I say B is just 4. I can say this one is just what? I can even write this one as this. It means that this C is equal to the universal set. But there is no number you will see here that is not here because this question, this is the universal set. Everything under consideration. All the elements under observation. That is what? The universal set. Now, we are looking at set notation. Okay? Set notation. How do you represent set? There are 2 ways. The first one is roster or the tabular form. Okay? We also have set builder form or the set builder notation. This one is the roster notation. Now, if you see something like this, A, if you see something like this, A as equals to 1, 2, 3, 4, 5. This is what? The roster form or the tabular form using the curly braces. If you want to use the set builder notation to also represent this, you simply say A is equals to, you put S here, you now write S is a natural number less than 6. This actually should be on the same line, okay? This is S is a natural number less than 6. We are describing this. So you can be given this and asked to get this. This is the builder, set builder notation. This is the roster method. Let's look at this example. This is representing a set of numbers. But what numbers? We want to write them out now. This is the set builder notation. We want to use the roster method now. This is the element of the set. This side is describing this. Okay? It's saying S is the element. Say for instance, say A is equal to this. We are saying S is element of A such that S is a natural number and S is less than 10. Are you getting it? S is element of natural number. S is less than 10. Let me show you how to write them. What are natural numbers? Natural numbers start from 1 to infinity. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are natural numbers. Right? Now, how do you now write A out in the standard convention, which is the roster method? You simply write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What are you doing? They told us that this S such that S is element of natural number. These are all natural number. They told us that what? This natural number, they are less than what? 10. Because they are less than 10, this is even wrong. I shouldn't put this 10 here. Because less than means less than. That means 9 should be here. Okay? Less than 10. So this is like a description. This is what? Writing out what this guy is describing. Okay? We are looking at what? Builder notation and roster. Let's see the next one. Look at this. It says, this is the element of the set. What is S? It's telling us about S now. It says, number one thing you should know is that S is element of natural numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is the first information. Okay? The second one is that S is less than 15. All the natural number we are considering is from 1 to 14. The next one is telling us more about X. S is even number. That means we are going to consider the even number between 1 and 15. So, to write them out now, you agree with me, 2 is even, 4 is even, 6 is even, 8 is even, 10 is even, 12 is even, 14 is even. If I write 16 and 16 is more than 15, then I stop here. So this builder is actually describing these elements. So you can see all these are natural numbers, correct? They are all less than 50, correct? And they are all even numbers. You get it? Let's check the next one. As you can see here, S is the element. What is the element? The element is a natural number, okay? This element is less than 12. S is odd, okay? Now, we are going to look at all the odd numbers between 1 and 12, okay? That is 1, 3, 5, 7, 9, 11. That is all. Let's see another one. What is this? This is simply saying that what? S is element of this. And what are these? Void. From this now, when we are talking about builder notation, you can put this roster inside builder notation. Anything can happen under builder notation as long as what you are describing, you get it right. I can even put here now, instead of this, I say S is element, or I say S is a void. It means all void should appear. So finally, you agree with me, we are simply going to write this. Look at this. You say S is a natural number. S is less than 20. S is prime number. So all the natural number less than 20 will be considered. Not just all of them, those that are what? Prime. It means to write out the actual elements, consider 2 because it's prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11, 13, 14 no, 15 no, 16 no, 17, 18 no, 19, So you can see these are prime numbers less than 20. Let's look at the next one. As you can see here, see the way we are describing this. We are using what? Inequality. What are we saying? S is a natural number. What is S again? S is between 5 and 15. All the numbers, all the natural numbers between 5 and 15 should be considered. Remember, here 5 will not be considered. Unless we put equal to here, we start from 5. Okay? The same thing, we are not going to include 15 because it says less than 15. 15 is not less than 15, unless we say all equal to. But that is not there. Since 5 is less than S, we start from 6, 7, 8, 9, 10, 11, 12, 13, 14. We stop here. So these values are between 5 and 15. Now, let's look at the next one. Here, S is a natural number. S is less than 20. When you see this, we are saying what? Multiple of 3. So all the multiple of 3 less than 20. That's what we're going to consider. So, what are the multiple of 3? 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, 3 times 7 is 21. So, we stop here. Because multiple of 3 less than 20. Let's look at the next one. What is this saying? It's saying to get S, we need to square n. But we don't know what is n. It's not telling us the meaning of n, that n is element of natural numbers, 1 to infinity, any of them, okay? And also this S we saw before is actually less than 50. Oh, less than 50, okay? Remember, this is for x, not n. We want to build each x. From here, this is S. S is equals to n. N, natural number. The first natural number you will see is 1, right? We square it, we have 1, okay? 2, we square it, we have 4. 3, we square it, we have 9. 4, we square it, we have 16. 5, we have 25. 6, 36. 7, 49. 8, 64. More than 50. Remember, this one is talking about all this S now. So this X, none of them should be more than 50. We have to stop at 49. But this guy is helping us to get each of them. He said, the S, you need to square each n. But what is n? N are element of natural numbers. It means we should go back to natural number and square each of them. That is how to get x. But don't allow s to cross 50. Don't allow it to get to 50. Then we stop. Let's look at this. As you can see, s is element of what? When you see this, this means integers. Integers. Okay? He said the integers are both negative and positive integer. All are greater than minus 10 and they are at the same time less than 10. And s is odd. That means all the integers we are going to consider, they are odd. Between minus 10 and 10. Okay? It means we're going to start from the odd. Here, minus 9 is odd and is greater than minus 10. Another odd is minus 7, minus 5, minus 3, minus 1. Next is 1, 3, 5, 7, and 9. Look at it. Okay? And 9. These are what this is describing. Now, let's look at some questions. Look at this question. It says, identify the type of set. This is what? A finite set, because it has beginning, it has an end. This one is what? Identify the type of set. S is a natural number. Because it's a natural number, there is no limitation. No limitation is defined. it means that this word, it is infinite. That means all the natural numbers which you can never get what? To the end. Look at this. Identify the type of set. When there is nothing in a set, it's an empty set or a null set. Null set. Identify the type of set. As you can see, it has beginning, it has end. Finite set. Identify the type of set. S is a prime number. Prime number without an end. Infinite. Identify the type of set. As you can see, only one value is here. Only one value. It means what? Singularity. Identify the type of set. As you can see here, beginning to the end. Finite set. Identify the type of set. N is an even integer. Even integer. It means there is no end. All the even integer. Infinite set. This is what? Finite. It has beginning. It has an end. Can see I'm dropping some of the numbers because I don't want to do repetition again. Identify the type of set. As you can see, 0 is here. It's not empty. There's something there. 0 is a number. That means singularity. It's not null set. I believe with this now you can identify different type of sets. Okay?